Actually, I'm having an issue with, well, let's see if this thing works. Okay, so, let's see. We're going from chapter 6 today. Um, there's not a lab today, so you don't have to worry about that. This is just basically to finish up chapter 6 is what I'm going for here, and then we'll continue with our labs on Monday and Wednesday next week. And gives you one less thing to worry about, I guess. So I'm going to go back from statics because I want to say a word about those. Oh, I thought we did 6, 1, and 2. Oh, okay. Oh, was it 5 that we were? All right, so gotta present this slideshow here. So switch, as I said, I think we sort of ended somewhere around here talking about switch statements. And the thing about a switch statement is that, let's take a look at an example here. This is an example of a grade book calculation for, it's taking the numeric grade, dividing by 10, and switching on that. So in a switch statement, you put in the value of, you put in a variable basically that you want to switch on. So in practice, like an if statement, for example, would be like a, you'd say if grade div 10 equals 9 or equals 10 or equals 8, and then you have a big long if else statement, if else if. Switch statement allows you to get around that. I think there's actually a example of that up here, or no, there isn't. But I'll draw it on the board. The people online won't get to see it, but that's all right. So what I'm saying here is, like, think of it this way: if you've got if grade div 10 equals 9, then do some stuff, else if grade div 10, let's start with, let's say 10 here, and do some stuff. Then you have another else if grade div 10 equals 8. And each one of these would have, so like in the case of 9, you would have plus plus a count break. In the case of 10, it's doing the same thing, plus plus a count break. So switch statements allow you to do, let me just move this, that way they can see what I've drawn on the board there. So switch statements allow you to do a couple things here. One is they allow you to get rid of this really long, because you can see this just does up to 8. Then we would need another one for else if for 7. We would need an else if for 6, and it would go on and on until we get all of our cases covered. So a switch statement allows you to make that look a little better, a little cleaner. You first have to ask yourself, well, okay, what are we switching on? So in this case, we're switching on the grade divide by 10. And that's the thing that is going to be checked for in each one of these case statements. These are called case statements here. We've got a case statement for 9, 10, 8, 7, 6. On the next page, you'll see the 5 and the 4 and the 3. Well, actually, it just defaults, which I'll get to in a second. So these case statements is basically like we're saying, if grade div 10 equals 9, then do this. If grade div 10 equals 10, then do this. Now the special case here is that case 9 has colon, case 9 colon, and then case 10. That is because it's what we call a fall through case. So case 9 and 10 are both going to go and do this. They're both going to add to the total number of A's that we've given out. Case 8 is going to add to the total number of B's that we've given out. Case 7 is going to add to the number of C's. So this is shorthand for basically saying if grade div 10 equals 9 or grade div 10 equals 10, then plus plus A count and then break. The thing about break is that here, break isn't really needed. I wrote it just to make this more of a one-to-one analogy. But normally you wouldn't write break in an if statement because it's going to do this and then it's not going to do the rest of this stuff because it's got else if logic in here. So it's going to go here and then it's done, right? Because this is all one big long statement. It's an it's if statement and an else if statement and else if statement and else if statement. That whole thing is one big construct. Whereas here, if we don't break on each of these, it flows right through to the next case. So we need to break out of this because otherwise it's just going to flow through to the next case. Yeah. Not really. You can have like a switch grade less than 10 or something. Well, actually, can you do that? Yeah, you could, and then you could case on true and false. But that would be kind of strange. Like, I don't know, I don't think you'd do that very often. Because then you'd have like switch grade less than 10, case true, case false. I guess I have seen that, but not very often. Usually you're going to reserve your use of switches for things where you're checking more than 2 possibilities. Otherwise, you might as well just use an else if, an if else statement, right? So here we're checking amongst 1, 2, 3, 4, and then there's one more on the other page. So we're checking amongst 5 possibilities. I mentioned I'd get back to this default case, so this is where I'm going to talk about that. This is another special thing of switch. When we say default, that means it wasn't covered by any of the other cases. So it's going to default to this one. In that case, you got an F. So that's going to consider the case where it's equal to 5, 4, 3, 2, and 1. It's like an else, yeah. It's like a fall through, like the last ditch sort of thing that happens when nothing else is true. Right, and then break is required there. Oh, in the other one, right. In the other one, right, because in the other one, if you left out your break here, well, it's not going to be 8, 7, or 6, but it's going to be the default then. And so it's going to go through and do the default case, which you don't want it to do. At least not usually, you're not going to want that. Maybe there's a few weird cases where you'd want that, but for the most part, you're going to want to have a break. So your structure is like, I'll just draw on this part of the board so people can see on it. Your structure is basically going to be switch on some variable, and then case on some value, and then break, and then do whatever, and then break, and then case on some other value, do whatever, and then break, and then eventually you'll have a default, and then break. And you could have stuff in here too. You could have another do whatever, and another break right in there. So that's your general. I remember back to when I first started coding, I didn't use switch very often. So when I would use it, I would have to remind myself what the syntax looks like. You'll probably be in that boat for a while because if else comes kind of naturally. but switch is kind of a little weird because it includes these breaks. So you might want to remember where this is in the book, your market or whatever. That way, when you need to write a switch statement, you can remind yourself how the syntax looks, because that's probably the hardest part of getting a switch statement right. This is just describing the things we just talked about. In terminology, this is just called the case label. The case labels are these things here. These are the case labels. And the controlling expression is the thing inside of the switch. And so the UML diagram for this, I think this is probably around where we ended. The UML diagram for this is pretty basic, but it basically just shows you how this looks in pictorial form, where we have a case A, for example, case B, case Z, and then if any of them are true, it goes on to the actions for case A, and then a break, and then it goes on. And so this is how it should look. If you don't have the break there, obviously it's going to go to the next case and evaluate it. But you should have a break. That should be a normal way that you code it up. The case labels themselves have to have constant integral expressions. So think about what that means. That means you need to use things like integers, character constants. In the newest Java, you can actually use strings as well, which is an extension they made on whatever we're at now, 1.8. But normally think of this as character constants. That's just a special case of Java. Most languages, you'll have to use a character constant or an integer or something like that, constant variable, and that'll be what you switch on. Oh, 7 actually is where they added this. They added string support in 7, so you can now switch on just strings. So this is doing a zip code computation for these cities. So in this case, city, if city is equal to Maynard, it's giving us zip code equal to 01754. This is also a typical usage of a switch where we're actually setting, this is a variable that's outside of the switch statement, right? So it was declared above somewhere, but we're setting it inside of the switch. Presumably then we're going to use it down below to do something. So that's a pretty standard usage of a switch as well. Now you can also use the break statements inside of whiles, inside of for loops, inside of do whiles. So now that you know break, you can make use of this. That means that things like while, this is something I mentioned in a couple of my classes this semester, you can do things like while true, break. This breaks an infinite loop, for example, because it breaks straight out of the while and actually goes back down here. So break, if you've got a for loop, I should be writing this stuff up here. That way they can see it online. If you've got a for loop, and you do a break in here, this will go down here. So it breaks out of whatever the current context is and goes on and does the next one. That can be useful. Like for example, if you want to only count up to a certain number, you can say, if count is 5, terminate the loop. In this case, it's kind of a trivial example because, well, why wouldn't you just stop at 5 in the for loop, but there are going to be cases where this might be useful. For example, like what if the user entered Q or something, you know, or did something where you want to bail out, you could use a break. Continue is also very useful in loops, because what continue will do is kind of similar break, except it will actually skip the remaining statements of the loop body and then go back to the top of it. So continue will essentially say, like, let's say we want to do something like print everything other than, let's have this go up to 5, and let's say we want to do a system.out.println on I, but we don't want to do the number 3. So we could say if I is equal to 3, continue. What this does is then the continue goes back up here, and so it won't print the 3. It won't get to this spot of the code. It'll say I is 0, so it's not 3, so it prints it. I is 1, so it's not 3, so it prints it. I is 2. Once it gets to 3, it's going to say, oh, I is 3. I'm going to continue the loop from the last spot that I was at the last time I incremented it. So it goes back to the top. It doesn't execute the rest of this loop, and you get it to skip printing the 3. This is showing what I just showed. So for logical operators, these are additional things you can do when you're doing your if statements. You can use conditional AND, you can use conditional OR, you can also use Boolean logical AND, Boolean logical OR, and logical exclusive OR, which is also known as XOR. And these last ones are bitwise operators, and we don't usually spend much time on them in 256, but we cover them in much more detail in things like machine organization and architecture. The top two you really need to know, the conditional AND and the conditional OR, because you'll use those many times. With the conditional AND, both operators have to be true for that the result of that expression to be true. We use what we call truth tables, and you'll see these in 240 as well, cs240, to represent these. So the idea is that if you say expression 1 ampersand ampersand expression 2, you're going to get various results back. If either one of those is false, you're always going to get a false back. If they're both true, you get a true back. So this is what we call a truth table, and that's the results of what each one of those would give you in that case. The OR basically says as long as one is true, we're going to give back a true value. So the only case that an OR would give you back false is if both are false. The parts of the expression containing the ampersand and the OR are only evaluated until it's known whether the condition is true or false. This is an interesting side note, because this is what we call in programming language short circuit evaluation. So let's say you've got something a little more complex. Like the easiest example here is we could say if A system.out.print both are true, so that's the easy example, right? You've got two booleans, and you're only going to print it if they're both true. That's sort of the typical starting point for conditional logical operators. But let's say, so we know already that methods can return booleans, because we've talked about how methods can return values. So we could have something like class I'm just going to call it foo for lack of a better thing, and I'm going to have a method called public boolean actually I'm going to call it my true, and this is going to return true always. And I'm also going to have a public boolean my false, which returns false. Then inside of main, I'm going to have my public static void main, and I'm going to say if my false or my true, actually let's say and my true, I'm going to say from main here, and then I'm going to make an additional change in this code, and I'm going to say that each time we call my true and my false, we return some, or we print out something. So I'm going to say system.out, just to indicate that my true was called, kind of a tracer. And then I'm going to do one here, system.out, .print. Oh, I'm going to make it a print line, my false. So what I'm about to tell you is that if you do this, and you write this code out here, you're going to test my false. So we're saying my false, which is going to return false. So false and my true, then print this. Well, first of all, so if we look at the output for this, the possible outputs are my true, my false, and from main. We know that my false, as soon as it gets in here, this is going to return false, and so therefore this this part of the code won't execute, because basically my false is returning false, my true is returning, so we call my false here, this returns back false, my true returns back true, so false and true is false, so therefore this doesn't print. But also what's interesting is that, so we know that as soon as my false is called, this is going to print out my false on the command line, or on the console. One would probably expect that the next thing that's going to happen is now my true is called, and it's going to print out my true. Because of short circuit evaluation, this isn't the case. Because what happens is this will never be printed due to short circuit evaluation. The reason is because here we've got a false. So think about what that says up there. The parts of an expression containing ampersand, ampersand, or operators are evaluated, the pipe, are evaluated only until it's known whether the condition is true or false. So here, as soon as we see that we've got a false and we've got an ampersand, there's no possible way for this statement to be true any longer. As soon as we have one false, we know that, and we're dealing with an ampersand, it's a logical and, we know there's no way for that to be true. So it's going to short circuit this thing, and it's not going to call my true. So that's an interesting thing of Java. Some languages don't operate that way. C is one. So this will not execute. We knew that. That's an easy part. So if you don't understand that yet, definitely think about that for a while. That's an easy one because we got false and true, and that's false, and so this never prints. But one might think that, well, what's going to print is my false and my true, because you get in here, it prints my false, you get in here, it prints my true. But actually, it won't print the my true because of short circuit eval. So lesson there is that if you're writing code like this, you have to think about, you know, if there's something we were doing inside of here that was important, we better make sure we move that somewhere else, because it's possible it's never going to get called. So you have to think about what you put in there, because it's possible that if you use it in an and, it's just not gonna happen. And then, as I said, we get into these ones a little more in 353. These ones always evaluate both operands, so this one does not do short circuit eval, so that's one difference of it. We can also have bits, and we can do a Boolean logical and on them, so that we end up with the logical inclusive OR of that operation. And this is the part, you're not going to be tested on this or anything, but this was where if we did, like, for example, a 101 ampersand with a 0100, the result is 0100, right? So that's these logical operators allow you to do this kind of math, this is pretty much standard in cs240. I mean, I'm assuming he's going to cover that if he hasn't already. So so as I said, we don't really deal with that much in 256, but it will come up again in 353. Also, an interesting one is the Boolean logical exclusive OR operator. This one is used also in 353 quite a bit. This is called an XOR. XOR basically says that for the exclusive OR to be true, only one of them can be true. Otherwise, it's going to be false. So it's an OR. So if it's false or false, that's still false. If it's true or false, it's an OR, so it's true. If it's false or true, it's an OR, so it's true. But if it's got two trues, it's kind of like you're saying either or. You're not saying both, you're saying either or in an exclusive OR. You're not saying you want, you want two things. You're saying you want one or the other of those two things. You're not saying you want both of them. So if that's the case, both expression 1 and expression 2 are true, then we get false. So that's how an exclusive OR works. And that's a little bit weird, because technically this is more how we operate in English, in the English language. When we're saying I want one of something or the other thing, usually we're talking about XOR, because it's usually not true that, well, we're okay with having both. We just want one of those things. We don't want both of them. So probably the easiest way to think of this is like an English meaning of either or. It's probably the easiest way to think of it. The other logical operator we have is the not. This is called the logical not, or logical negation. In this case, we take the result of whatever that Boolean is, we put an exclamation mark on it, and we get back the opposite of whatever it is. So if we got a Boolean that's false, and we put not on it, so if we've got like bool a equals true, bool not a, we could say not a, and then we've got the results of whatever wasn't in a, basically. And that's a very easy one to look at the truth table on. This is showing the results of a bunch of these, just sort of truth tables. And sort of a summary of precedence. Note that for the most part, it does the conditionals. Like the assignments are always done last. For example, the things like unary postfix, like plus plus and the whatever it is, plus plus or plus plus and minus minus, those are all done first. And then we've got any additives. Then we've got the logical conditionals that happen after that. So chapter 6, which I almost fast forward us to today, is going to talk about method-based programming. Everything we've looked at so far in chapter 5 has been just tools you need to do structured programming. Single entry and exit statements, connecting statements from one piece of the program to the other, such as if-else statements, selection statements, control statements such as for loops. These are all things that we use when we say we're doing structured programming. So that's just showing the selection sequence, and just a summary showing repetition for the do while, the while, and the for. So when you're doing structured programming, these are the rules that you can use if you're thinking of how you're going to make this work. Start with a simple activity diagram, and then any action state can be replaced by two actions in a sequence. And then you can start working in your if, your else, your switch, your while. And you can do that in as often as you want. You can keep adding to those, and refining those. So what they mean by that is this is our simple state. We're just in one state, and now we're going to add to that. We're going to add an if, or we're going to add whatever. We're going to add another action state. So all of these that we saw here, here's an if statement, here's a switch, here's an if else. All of these are just actions that are added to. So structured programming is literally we're just adding all these constructs on top of each other. We're doing one thing after another. In some cases, we're repeating things like it shows here. But we're just doing one thing after another sort of sequentially. And what that looks like from an abstract level is we're taking an action, we're doing it, and then maybe we're going to do another action based on that. We're going to repeat. You can see there's a loop in here on that one action state. Maybe we're doing a selection then to see if we should do another loop. So Bowman-Jacoponi, I think I'm pronouncing his name right, two famous CS people, math people, basically said that there's three forms of control that you need to implement any algorithm: sequence, selection, repetition. So we've sort of covered those in this chapter. Here it's just the sequence of the statements to execute in which order they should be executed in. Now, we're going to talk about method-based programming, procedural programming next in chapter 6. And then obviously this whole class is about class-oriented design and object-oriented design. And eventually it's going to lead into 316, which is the inheritance stuff. But really, Bowman-Jacopini, are correct in that at the end of the day, all that class-based design, all that method design, all that fancy stuff, the object-oriented inheritance, whatever, it all actually funnels down to structured programming, just like we've covered here in chapter 5. Because if you think about it, and we talk about this a lot in 353, at the assembly level, it's all just a sequence of things that are going to be executed. Even when we get to inheritance, we'll see that when we inherit from a class, say we've got an automobile and we're going to inherit a Jeep and a sedan or something from automobile. That Jeep and that sedan, they're going to have common code, and that's the power of inheritance. But that common code is all still selection sequences, repetition sequences, and when it's compiled down to the computer, it's still structured programming. So this is sort of the foundation of a lot of what we're going to be talking about in this class and other classes. So in Java, we've got if statements, we've got if else, and we've got switch. This is sort of just a summary. Those are your 3 ways of doing selection. We have whiles, do whiles, and fors. Those are your 3 ways of doing repetition in Java. If we combine these, we can come up with any sort of combination of those that we want to express any Java program in terms of a sequence of doing, and when I say sequence, I literally mean like this. This is a sequence. Bool A equals true. Bool not A equals not A. This is sequence. All sequence really means is we've got a statement on line 1, then a statement on line 2, then a statement on line 3. We're just going down in order. And then sure, every once in a while we might need to add an if statement. And we may need to add a while. And what's more, it's actually more fundamental than this, because I mentioned that with selection statements you've got if else, and switch. But you could do everything in an if statement. You could do everything in a while. Every for loop you could replace with a while loop. Every if else you could replace with an if. It would make it inefficient, but you could. Instead of having like if you've got something that says if grade less than 70, else if grade, actually let's say greater than 70. You could take this is an else if statement, but you could take this and you could say, okay, well, I don't want to use the else anymore. I want to use just ifs. So I could say if grade greater than 60, and then you use your ands that we just learned. Grade less than 70, and then we've essentially just done this. And whatever you'd have here would be freer to qualify whatever's above. But you could take in every switch statement, every if-else statement, you could, using what we just learned with logical conjunctives, you could create what you need. And we're going to, well, actually, yeah, we can cover this very quickly. This is an optional section. I usually like to cover these. This one talks about drawing rectangles and ovals. There's a draw rect and a draw oval class, and actually I think we'll probably do this for lab next time, because it's been a while since we did a drawing lab. So for draw oval, we create this imaginary rectangle around the oval called a bounding rectangle, and those are the midpoints, and that represents the midpoints of the oval that's inside of the bounding rectangle. So we have to use java.awt.graphics to make this work, and jpanel. And this has us doing a switch statement where we either draw a rect or an oval, and these are the parameters of the oval, these are the parameters of the rectangle. And based on what we pick, we either draw a rectangle or an oval. And so we're parsing the int here to decide which we're going to draw, whether it's a rectangle or an oval. And that's in the JPane, and then this is drawing the rectangle. This one's drawing the oval. So we'll do a graphics lab next time, because as I said, it's been a while since we did one. But I didn't want to do a lab today just to give sort of a little break. So that's about all I got, and we're just about at the end of the hour anyway. So So any questions on chapter 5 content? We'll actually do chapter 6 next time. So, all right, so we'll see you on Monday. Have a good weekend. No lab today.